Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about optical detectors. So what are optical detectors? So these optical detectors are used to capture the light signal from the optical fibers at the receiver side to process the light signal and get the information signal. So these photo detectors find applications in the area of medical, automotive, safety and analytical equipments, cameras, communications, etc. So types of photodetectors are photodiodes, photodiode arrays, light dependent resistor, avalanche photodiodes, photomultiplier tube, and position sensitive detectors CCDs. So first of all we shall see the pin photodiodes and their operation. So the pin photodiode is the PIN structure where p-type, n-type and intrinsic region is there. So the pin structure increases the distance between the p and n conductive layers. So therefore it decreases the capacitance, so increases the speed. So the volume of the photosensitive region also increases, enhancing the conversion efficiency. So the light signal is detected very efficiently. So the bandwidth can extend to tens of gigahertz. The pin photodiodes are preferred for high sensitivity and high speed at moderate cost. So we have a top metal contact p-type region, intrinsic region. So this is the larger depletion region, and n-type, and we have a contact regions and metal contact. So this is the construction of the pin photodiode. So in the basic construction, it has the highly doped transparent p-type contact layer on top of the undoped absorbing layer, it is the intrinsic layer, and an n-type highly doped contact layer on the bottom. So this diode is evolved mainly from one basic requirement, that is light should be absorbed in the depletion region of the diode to ensure that the electrons and holes are separated in the electric field and contribute to the photocurrent, while the transit time must be minimal. So this implies that the depletion region larger than the absorption line must exist in the detector. So this is assured by the making the absorbing layer undoped. So the depletion region is undoped region. So only a very small voltage is required to deplete the undoped region. So the advantage is that recombination time constant is longest for undoped material, which provides the minimal thermal generation current. So here next is the avalanche photodiodes, photodetector with internal gain. Here we have four regions. As we can see in this diagram, there is an N region and below it is P, and then I region, which is absorption region, and P region. So here photodiode with internal gain, it is the main advantage. So internally multiply the primary signal photocurrent before it enters the input circuit of the amplifier and increases the receiver sensitivity. So the photocurrent is multiplied before encountering the thermal noise associated with the receiver circuit. And for carrier multiplication, the photo-generated carriers must traverse a region where high electric field is present. So in this high electric field region, photo-generated electron or hole can gain enough energy so that it ionizes the bond in the valence band upon colliding with them. So this phenomenon is known as the impact ionization. So next, avalanche effect is used, where the newly created carriers are also accelerated by the higher electric field, so gaining the enough energy to cause further impact ionization. So this process is known as the avalanche effect. So the avalanche photodiodes combines both the effect of avalanche effect and impact ionization to produce the photocurrent. So it creates an extremely high electric field and requires high reverse bias voltages in order that the new carriers created by impact ionization. So the carrier multiplication factors are great as 10 power 4. So when carriers are generated in the undepleted material, they are collected slowly by the diffusion process. So when the APD is fully depleted by employing high electric field, all the carriers drift at saturation limited velocities. So the response time is limited by the three factors: the transit time of the carriers across the absorption region, the time taken by the carriers to perform the avalanche multiplication process. Next is the RC time constant. So it affects dominate, giving definitive response time and hence constant bandwidth for the device. So at high gain, the avalanche built up time dominates and therefore the device bandwidth decreases proportionately with the increasing gain. And next, the rise time between 150 to 200 picosecond and fall time is 1 nanosecond. Multiplication factor is the measure of internal gain provided by APD, is defined as IM divided by IP, where IM is the average value of total multiplied output current and the IP is the primary photo current. So it is the statistical process and not every carrier pair generated in the APD experiences same multiplication. So therefore the measured value of M is expressed as an average quantity which is as great as 10 power 4. So the advantages and drawbacks of avalanche photodiodes: it provides increase in sensitivity between 5 dB to 15 dB over pin photodiodes, that is the detection of very low level light signals, and wider dynamic range as a result of gain variation with response time and reverse bias. And drawbacks are fabrication difficulties due to their more complex structure and hence increased cost, the random nature of the gain mechanism which gives additional noise contribution, and high bias voltages required, and variation of the gain with temperature. This is the comparison between APD versus spin photodiode, and performance characteristics of various photodetectors are shown between silicon, germanium and indium gallium arsenide. Can have assessment. First question is, the depletion region must be dash to allow large fraction of the incident light to be absorbed in the device. Example, photodiode. So the options are first one thick and thin region, long and inactive. So the answer is first one thick. That is the depletion region in PN photodiode. The intrinsic conditions are created in the depletion region. So the depletion region must be thick in order to achieve a maximum carrier pair generation. So the answer is A. And next question is, electron hole pairs are generated in first one depletion region, second diffusion region, depletion region, p-type region. So the answer is depletion region. So where photons are absorbed in both the depletion and diffusion regions, the position and width of the absorption region depends on the incident photon energy. So the answer is C. Thank you for listening.